afternoon, everyone. Sorry for delay. And as this industrial section, I thought that it will be more interesting to show you some code. So as you can see, you can find it on GitHub. Does anyone want to see link? Okay. So it's just simple. And pretty much the first repository there. Okay. This lecture will be about how to make it quicker, how to speed up your code in Python. So if you do not like Python, if you prefer R, I don't think it will be very useful for you. And maybe you should go and hear another lecture. Okay. Let's start. Zara? Thank you. There are two big problems when you work on the same server or when you work in a small laptop with not lots of RAM and when you do not have GPU, for example. There are two problems, space and time. In one project, I have the raw data that took about, I think, 30 gigabytes, and it was the first try, like really raw data, and they become bigger and bigger when we created some features. And it was a problem how to use it, how to analyze them in the machine when you share with others, your colleagues. And I started to explore this problem. Actually, my lecture will be like a synopsis of some useful features that helped me to create features, new variables, that will not take like several hours. And the first part of my lecture will be about space. Okay. So, as you can see, we have like quite big pandas data sets. And when we ask pandas with like this info function, how much memory does it use? It says like it's about 200 megabytes, plus minus. And when we ask, okay, maybe you'll think about it, how much exactly does it take? We find out that it took like 800 megabytes. How does it work? Why do we have such problem? Actually, because when we ask pandas about these object blocks, it just counts how much of the object blocks it has and then multiply by constant, some constant. When in fact, like every this cell in string cell has different size. And when we ask pandas, please go deeper, find out how does it take, how much does it take, we find out that it is 600 megabytes more just in this string object data. And I don't know, as for me, it's quite a lot. So how can we optimize this? Let's count. For the float columns, we have like average usage of a float column is 1 megabyte. Average usage of the int column is 1 megabyte. And when it goes to the object column, it's almost 10 megabytes. maybe we can do something with it. So first, let's go with integers, with just with integers. Okay. Which type is the most common in pandas for integers? Maybe you know. What's the default type for integers? Really? Okay. It's a little bit hint over there. So it's int 64. It took 64 bytes for every integer. Like even if you have integers like 0, 1 in column, no, it's still int 64. And sounds like quite overrated. And actually, we can quite easily downcast some of these variables and more or less quit them. Should I make some comments about these parts of code? Okay, please, if you have any questions, ask me. It will be quite useful for everyone, I think. Okay, no questions about this part of code. Okay. So, after we optimize this variable, after we downcast this variable, it took only 1.5 megabytes versus almost 8 megabytes before. So, only with a couple of lines, we saved, okay, more than 5 megabytes. It's not so much, 5 megabytes. What's it about? But imagine that you have not 20, 30 integer columns, but maybe hundreds, thousands. Think about it in percents. This Jupyter Notebook was designed to make it quite quick, that you can try everything on your laptops. We'll go there. Okay. So if you do the same with float, we can see that every variable that was in float 64, we can put in float 32. And we can save half of the space that was used by float columns. Okay, so we are We are winners. Okay, no questions. Great. And what about string columns? There's object columns. Here it is, actually, how Python saves NumPy array and Python lists. As you can see, in a NumPy array, there is a link for actual values. And in Python list, there is a link, two links that show us actual variables. This is the main reason why, when we just ask pandas info how much memory does it take, it's why it says like 20 megabytes, 200 megabytes plus minus. This is mainly because of this way of saving Python list. Okay. So let's think about it. If we have, there was a variable day of a week. And actually, it has not so much unique values. Not more than 7, I think. And if we think about it, we can save it, we can deal with it like with a categorical variable. So, and if we save it as a categorical variable, we have two instances, like a number array with integers in it, and something like dictionary. And it takes really not so much space. Let's deal with it, and let's convert our object variables to categorical variables if we can. And after that, we had like 750 megabytes, and after our converting, we have only 50 megabytes. Like, again, with several lines of code, we saved 700 megabytes. I think it's really, really nice. So, yeah. After all, we have like only 100 megabytes in use. Nice. And what about data columns? Now we are saving them where like there will be just integers, actually unsigned integers. But we can easily convert them to proper formats, like date time. And even after that, we have only 100 megabytes from all data set, which before takes about 800 megabytes. It's like 8 times smaller. And it's surprisingly helpful when we talk about your big data sets in Kaggle, or when it becomes to real projects, when you have like 30 gigabytes, 50 gigabytes of data. Okay. And there is another useful trick. It's the way of saving this data. Because if you save it like just to CSV, it took in average 5 seconds, and if you dump it with joplib, it uses like 130 milliseconds. Quite faster. And which more important as for me, when we load this data from joplib, it remembers the right data types, and it's still, this memory usage will be quite small. But when we read it with pandas, just read CSV, it's pretty much the same. You should do all over again all these optimizing functions, which is quite boring. So, yeah. Okay, still no questions. Maybe I should go faster, if it's all obvious for you. Not faster, okay. Group by. Group by is really, really slow procedure. When I have a project when it just row group by took like several hours to create only one variable. And it was quite annoying. And when it's obvious question, could we parallel this group by? The answer yes, we can easily parallel this group by operation. And when we here in this example, if we have like n jobs equals 10, it becomes, I think, 2 times faster. But we can go further. And we can make life of group by function quite easier if we make this variable data chunk. What it is about? We help group by and divide this data set in data chunks before. And when we give to already paralleled function this data already divided in number of parts that we need, it becomes 6 times faster than just row group by. Again, with just 2-3 lines of code, we speed up it 6 times. And this just checking that it's still the same. Yep. State what's going on. Okay, I will not do this again. So yeah, still several lines of code, 6 times faster, no other difference. Okay, join VC merge. Maybe everyone knows that join is faster than merge. Okay. Actually, yes, it's faster. Like it's, oh my gosh, no, please do not do this. Okay. It's faster like 2 times if we set index in this function, in the middle of join function. And it's 8 times faster if we do it before, set indexes before. But the important idea that the left join is really faster than inner join. Also 4 times. And if you want to make an inner join, please just make a flag variable and then drop an R in it, and it still will be faster. Okay. So, and this is about creation new variables. Imagine that we have a function to count distance between 2 points in city, and we want to find out what the distance between this hotel and, for example, the Central Park or Times Square is. The data set about hotels in New York. No, in the United States. And how do you apply this function? Okay, really, never do that. Never make this like big for that go through indexes of the data sets because it took like enormous amount of time and it's just awful. Not good code style. You can make it a little bit better if you use just iteros, but still it will be quite long, quite unreadable. We can do better. We can do it better. If we use apply, it will be 10 times faster than this for loop all over indexes. But we can go further, and we can remember about vectorization. Does everyone know what's vectorization? Yeah? Great. So if we use vectorization, if we treat a series of floats like a variable, it becomes like almost 40 times faster than just apply. But we can save a little bit more time if we treat it not like pandas series, these variables, latitude and longitude, not just like pandas series, but as NumPy arrays. It becomes faster after just adding dot values in the end of every variable. I think it's quite amazing. Okay. And after that, we can try to make it with Cython. Does everyone know what Cython does? Come on, guys. Do you have any questions? Is it easy for you? Do you know everything? What's going on?
It's not comfortable to speak with lecture.
Sorry?
It's not comfortable to speak with lecture.
Please, we have lots of time, and
It's not the reason of silence.
it's nice. I still not believe you, do not believe you, but it's nice. Okay. And if we use it with Cython, let's see the results. Okay. Just Cython tries to convert this Python code to C code. And after that, when we, oh my gosh. Oh, yeah. That's the end. It becomes 300 microseconds. Does anyone remember what was before? Pretty much the same that with NumPy array. But Cython still very useful if you do not have such easy function. Because, you know, C is really, really fast. Oh, I forgot to translate something. And yeah, after that we can try to put some, bless you, number over it. So, and we just, we put AutoJIT over the harvesting function, and it will be pretty much the same. 300 microseconds. Another important thing that I wanted to show you that this vectorization works not only with numbers, but also with string variables, object variables, still like 30 times faster. Okay, and now I hope all results will be there. I wanted to show you some more examples, some more tries with Python and Numba. So yeah, still lots of Python code. And it just comparing of different ways of variable double. And with no number, it's like just a function that doubles a variable. It's 700 microseconds with just double. It's 300 microseconds. With number, still 100 microseconds. With after number, with just this AutoJIT word, it's 100 microseconds. Like, you actually do nothing. You just type AutoJIT, and your function becomes 7 times faster. And I put it on GitHub when not all results were there, so okay. You just can't believe me that with CPython it's a little bit slower than Numba. Yeah. So it's pretty much that I wanted to tell you. And if you have any questions, please ask me. There are really lots of interesting links that I highly recommend you to look through. Because, as I said in the beginning, it's quite a synopsis of useful tips and tricks that I found out during my research. So, yeah, that's all. Thank you.
So I think we have about 10 minutes for different questions. Everyone, yes?
Thank you. My question is about memory usage and medium representation.
Yeah.
Can I apply these methods for PySpark data frame when I run my scripts at Hadoop cluster?
I'm not quite sure, but I think you should try.
Because PySpark data frame is different from Pandas data frame, and the functions there are different. So, and I can convert to Pandas big data frames. So it's also a problem how to make faster it on cluster. Did you try something like this?
No, actually, no. I'm sorry.
Okay.
Any more questions?
Yeah, I'm not that familiar with Python, so maybe some dumb question. What is NGIT?
AutoJIT is just in-time compiler. As far as I understand, it takes Python bytecode, then it optimizes it, and then use it.
Okay, then don't you think that all this stuff is just some kind of magic? Because there's Java which does JIT for everything.
Yeah.
And automatically detect. It manages to detect hotspots and compile them, and everything is okay. And here you have to have bells and whistles to select what to compile manually and so on.
Yeah. Number is a little bit of magic, and it's one of the cons because you have not lots of opportunities to optimize, and this AutoJIT, it's like, please make it faster, please. But usually it makes faster. And if you want to be in charge of it, you can use CPython. You see, like, everyone likes C, lots of C codes. And here, really tries. Here I just make this function like cpdef, cpythondef, but you can go further and make this part of code, write this part of code in C, and hey, it will be your ways of optimizing. But yeah, JIT is like, nobody's like magic.
Yeah, but that's a bit strange because, okay, Python is extremely high level.
Yeah.
And then you say, okay, please optimize and go extremely down to C.
Yeah.
Oh, there's Java in the middle, it's okay.
Yeah, but everyone is familiar with Python, and there are lots of useful libraries. There are lots of, I don't know, kernels in Kaggle, papers that are written about Python with code on GitHub. And when you actually, I had this problem, and I tried to find some libraries, some projects about data science in Java, and I go back to Python. I went back to Python. So,
Thanks.
okay.
Any questions? If not, I just have one. You said that you did some magic with categorical features, but some machine learning algorithms deal with these categorical features themselves. Does your magic affect the result of the algorithms that we use after that all optimizations?
I haven't seen the difference, but it's after my experience. It's in my experience, but yeah, I haven't seen the difference.